Part 3, Finding Roots of Quadratic Functions. To find the roots of a quadratic function, f of x equals ax squared plus bx plus c, set f of x equal to 0 and solve for x. That means the roots of a quadratic function are the solutions to the equation f of x equals 0. To find those solutions, if f of x factors, set each factor equal to 0 and solve for x. But if f of x does not factor, or you'd rather just use the quadratic formula, you can do that. Remember, the quadratic formula says that x equals negative b plus or minus square root of b squared minus 4ac over 2a. Let's determine the roots of this function, 2x squared plus 5x minus 12. We can factor this, or we can use the quadratic formula. If we want to factor, one way to factor would be to find two numbers that multiply together to get 2 times negative 12 or negative 24. And those same two numbers have to add together to get 5. So those two numbers would be negative 3 and 8, because negative 3 times 8 is negative 24, and negative 3 plus 8 is 5. Then you can do kind of some guess and check, or we can factor by grouping, which I'll show you how to do that here. Hopefully you remember this from a previous class, but if not, here's a quick refresher. So I can write my equation as 2x squared minus 3x plus 8x minus 12. Notice I split up the 5x into two parts, the negative 3x and the 8x, because negative 3x plus 8x does equal 5x. This is valid. This is still the same equation. And then I'm going to factor by grouping. The first grouping, I can factor out an x, and I'm left with a 2x minus 3. In the second grouping, I can factor out a 4, and I'm left with 2x minus 3. Notice now that both terms have a 2x minus 3, and I'm left with an x and a plus 4. So I have factored my function, and now I can set that equal to 0 and solve for x. So 2x minus 3 equals 0, or x plus 4 equals 0. In the first case, 2x equals 3, and x equals 3 halves. And in the second case, x equals negative 4. So the roots of f of x equals 2x squared plus 5x minus 12 are 3 halves and negative 4. Now, because these are real numbers, they are x-intercepts of the graph. If they were imaginary numbers or something with an I, then they would not be x-intercepts, but they would still be considered roots. Determine the roots of g of x equals negative 3x squared minus 12x minus 11. This function does not factor, so we will need to use the quadratic formula, which means x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. For this function, a is negative 3, b is negative 12, and c is negative 11. So to find the roots, x equals negative b, so negative 12, plus or minus the square root of b squared minus 4 times a times c all over 2a, and then we need to simplify that. So negative 12 is 12 plus or minus the square root of 144 minus 4 times 3 times 11, which is 132. We have 3 negatives, so it's negative, divided by negative 6. To simplify that, we have 12 plus or minus the square root of 12 over negative 6. You can leave it like that, or we can simplify the square root of 12 to 2 square root of 3, and then divide everything by 2. So we get 6 plus or minus square root of 3 over negative 3. So our two roots are 6 plus square root of 3 over negative 3, which is approximately negative 2.577. And our other root is 6 minus square root of 3 over negative 3, which is approximately negative 1.423. Equations quadratic in form. An equation that is quadratic in form means that even though the equation might not be quadratic, we can rearrange something or use some substitution to make it look quadratic and then solve the equation. For this one right here, if I get everything on one side, I have 4x to the fourth minus 13x squared plus 9 equals 0. This is not quadratic. Our highest exponent here is 4, not 2. But notice that x squared is x to the fourth. I have an x squared and an x to the fourth. So I'm going to do something called u substitution. It doesn't have to be u, it's just a variable, but most textbooks use u, so I'm going to use u. I'm going to say that our u is x squared, and then if I square both sides of that equation, I get u squared equals x squared squared, which is x to the fourth. Now in my function, or my equation over here, I'm going to substitute in u for x squared and u squared for x to the fourth, which gives me 4u squared minus 13u plus 9 equals 0. Now I can solve for u. To do that, I need to factor. I can do the same thing I did before to factor. 4 times 9 is 36, and two numbers that multiply together to get 36 and add together to get negative 13 would be negative 4 and negative 9. So I'm going to write this as 4u squared minus 9u minus 4u plus 9, and then factor by grouping. Remember, when you're factoring by grouping, you want a plus between the two parentheses. In the first grouping, I factor out a u, and I'm left with 4u minus 9. The second grouping, I'll factor out a negative 1, and I'll be left with 4u minus 9. I factored out a negative 1 instead of a positive 1 because I wanted this parentheses to equal this one. Now I can factor out the 4u minus 9, and I'm left with u minus 1. So 4u minus 9 equals 0, or u minus 1 equals 0. The first one gives us 4u equals 9, and u equals 9/4. And the second one gives us u equals 1. So I've solved for u, but I need to solve for x. The original equation wants me to solve for x. Now u equals x squared. So x squared equals 9/4, and x squared equals 1. If I take the square root of both sides of each equation, I get plus or minus 3/2. And here I get x equals plus or minus 1. So I have 4 solutions to this equation: 3/2, negative 3/2, 1, and negative 1. Let's try this one. Here what we need to notice is that y to the 1/6 power squared gives me y to the 2/6 power, or y to the 1/3 power. And I do have a y to the 1/3 power and a y to the 1/6 power. So I'm going to say u is y to the 1/6. If I square both sides, I get u squared equals y to the 1/3 power. So I have u squared plus u minus 2 equals 0. Factoring that, I get u plus 2 and u minus 1 equals 0. So u equals negative 2 or 1. So I've solved for u. Now I need to solve for y. Remember that u is y to the 1/6 power. So I have y to the 1/6 power equals negative 2, or y to the 1/6 power equals 1. To solve for y, I'll need to raise both sides to the 6th power. And I would get y equals 2 to the 6th power is 64, and y equals 1. Recall that anytime you're solving an equation and you raise both sides to an even power, like here we squared both sides, we need to check our answers because we could introduce what we call an extraneous solution. So a solution that doesn't actually work in the original equation. So let's check both of our answers. 64 to the 1/3 power plus 64 to the 1/6 power minus 2 equals 0. The 1/3 power means the cube root, and the cube root of 64 is 4, and the 6th root of 64 is 2. So I have 4 plus 2 minus 2 is 0, but 4 does not equal 0. So 64 is not a solution to this equation. You might have noticed right here where I have y to the 1/6 power equals negative 2. That means the sixth root of y equals negative 2. But an even root of something is not going to be a negative number. If you recognize that, we wouldn't have had to find what y is and substitute in 64 to show that's not a solution, but you could do that. The other solution, though, y equals 1. Let's plug in that. We have 1 to the 1/3 plus 1 to the 1/6 minus 2 equals 0. The cube root of 1 is 1. The sixth root of 1 is 1. And 1 plus 1 is 2. And 2 minus 2 is 0. This checks out, so our solution is y equals 1. If neither answer worked in the original equation, there would be no solution. Or they might both work, and we would have two solutions. Solve t plus 4 square root of t minus 12 equals 0. We can do the same thing here. If I let u equal the square root of t, notice if I square both sides of that equation, I have u squared equals t. So I could write this as u plus u squared plus 4u minus 12 equals 0. Factoring that, I get u plus 6 and u minus 2 equals 0. So u equals negative 6 or 2. I've solved for u. Now I need to go back and solve for t. U is the square root of t. So square root of t equals negative 6 or square root of t equals 2. Square both sides, and here I would get t is 36. Square both sides here, I would get t equals 4. The 36 isn't going to work for the same reason as before. The square root of a number is not going to be negative 6. But let's plug in 36 anyway, just to double check. If I plug 36 into my equation, I have 36 plus 4 times the square root of 36 minus 12 equals 0. Simplifying that, I have 36 plus 4 times 6 is 24. Minus 12 equals 0. 24 minus 12 is 12, and 36 plus 12 is 48. So I have 48 equals 0, which is not true. So 36 is not a solution. If I try 4 plus 4 square root of 4 minus 12 equals 0. 4 plus 4 times 2 is 8, minus 12 equals 0. 4 plus 8 is 12, and 12 minus 12 does equal 0. So that solution works. T equals 4.